So friends, in the last video, we saw that sun will die in a few billion years and how the sun will completely destroy the earth. Not only no human will be left on the earth, but also no creature will survive. The size of sun will grow big and sun may swallow the earth. And this is the second part of the video, in which we will know how the life and death of a big star happens. Stars which are so much bigger than sun. So friends, in part 1, we learned about brown dwarf, yellow star, and red supergiant stars. In this video, we will learn about white dwarf, blue giants and neutron star, which is the most interesting and dangerous star in our universe. In the previous video, we saw that yellow stars are formed from the clouds that are in space, called nebula. But the clouds from which blue stars are formed, those clouds are much bigger. Their diameter can be up to 100 light years. 1 light year is equal to 9.461 trillion kilometers. Therefore, there is a lot of gas and dust. So the star which is born is much larger, and the star has more mass. Therefore gravity will compress the core more strongly. So the core will also accelerate fusion. And the star will grow very quickly. And the fuel will also consume quickly. Stars like sun, they consume their fuel very slowly. So they have a much longer life. Whereas blue giant stars consume their fuel, that is, hydrogen reserve, very quickly. So their life is much shorter as compared to the yellow star. Now hydrogen fuses into heavy elements like helium, carbon, oxygen, neon, silicon and then iron. But iron doesn't fuse further. There's a very interesting reason behind it. If you want to know, be sure to tell us in comments. After iron the fusion stops. The fusion that pushes the star outwards. Because of its absence, gravity compresses star. That too with so much force. Stars such as sun, at the time of their death, their outer layers expand in space. And a white dwarf remains in the star core. White dwarfs are very dense. And their mass is half the mass of the parent star. While the diameter is same as the planet. White dwarfs consume their remaining fuel very slowly. And their lives can be hundreds of billions of years. So friends, now we are going to see that the big stars whose mass and size are much more than sun, how they die. Because of the huge mass of these stars, their outer layers doesn't expand in space. But here a very interesting phenomenon happens. Because of the huge mass of the star implodes violently. And this implosion is so violent that its brightness is visible in the entire galaxy. It is called a supernova. The mass of the star is very high. So as soon as the fusion process ends, gravity crushes the star with so much force. And the star collapses at a speed of about 25% of the light. That's why this explosion is so violent. And so much energy is releases in this explosion. Supernova explosion releases as much as energy, which is more energy than the sun releases in his entire lifetime. Now, here the things become a lot more interesting. After supernova, for the core of the star, all the things depend on its mass. If the parent star mass is less than 8 solar masses, then it becomes a white dwarf. And no supernova happen. The mass of the core of star means the mass of the white dwarf can reach a maximum of 1.2 solar masses. But the stars in which supernova happens, the mass of those stars is more than 8 solar masses. And after the explosion of the supernova, the mass of their core ranges from 1.3 to 3 solar masses. Then such a core is called a neutron star. And if the mass of the core is more than 3 solar masses, then that core keeps on compressing further and becomes a black hole. So let's discuss about neutron stars first. Neutron stars are the most dense objects in our universe other than black holes. Their density is so high that even a small piece of them can weigh from millions to billions of tons. The average neutron star's gravity is 200 billion times greater than Earth. And its magnetic field is 100 million to 1 quadrillion times greater than Earth's. Neutron stars have very high rotation speeds, about 100 times per second. And the highest rotation speed ever observed in a neutron star is 43,000 revolutions per minute, about 716 revolutions per second. That's insane. Black holes. Black holes are the most interesting objects in our universe. If the core of the star is more than 3 solar masses, then it collapses further and further until we get this radius of the core. This formula known as by Schwarzschild radius. Well, black holes are the most interesting objects in our universe. so it deserves a separate video. Therefore we are going to upload 2 videos on black holes. First part, about the formation of black hole and size of the black hole. Second part, we will be about time travel and the death of black holes. If you have any doubts related to science, then you can ask us your questions on our Instagram id. And if you want to see interesting facts, then follow our Instagram page and subscribe our channel and click on left for the part 1 of this video. Keep learning.